The whole idea of the Docker build process is to build an image that can be used later in a Helm chart for application deployments. This isn't limited only to Helm charts, meaning there are several other ways to deploy your Docker images. For example, you can use Scaffold instead of Helm. In this section, we will build on top of an existing Postgres image that was created by the Udemy team. What we'll basically do is to add our backup and restore scripts into a specific location in the pod. This way, when the pod is created, we can access them from there. You first need a Docker file to build your image. A Docker file is a special file like a YAML file is. So make sure your file is of type Docker file before you start your builds. One way to create a Docker file is via Visual Studio Code. As mentioned earlier, save your file as a Docker file. Now that you have your Docker file ready, let's break down the components of our custom Postgres Docker image. On line 1, we are defining the Udemy Docker image as the base image. This was the image that came by default from the Postgres Helm chart. Think of the base image as the foundation on which we build upon. Docker has a unique library of syntax it works with. You can see keywords like from, user, run, all serve a specific purpose. On the next line, we switch user to root so that we can create the home custom scripts and the home backups directories. On line 5 and 6, all we are doing is running the make directory command to create these directories in the image. The custom scripts directory is where we copy the backup and restore scripts, while the backup directory is where after a backup script executes, the backup file will be created. On lines 8 and 9, we are simply copying the backup scripts and copying them into the home directory of our image. Basically, we are baking it into our image. Note that the copy is from these two files in the same directory of the Docker file. So these commands are copying these files into the image. In Linux, you can't run any script unless it's made executable, and that's what line 11 and 12 is doing. The chmod +x command makes these two files executable. On line 14, what we are doing is making the user 1001 the owner of the home directory. We are doing this because the cron job will use this user to run the scripts. And so if this user does not have the ownership or privileges to access these files, the job will fail. Now a question that will come up naturally is, how do we know the user is user 1001? This I will show in a later section after the Postgres pod is up and running. Our Docker file is now ready, so we can build and publish our image to Docker Hub. Switch over to a terminal of choice. I'm going to use git bash for this, but you can use command shell, PowerShell, or any other terminal of your choice. The first command we're going to use is docker build. This command will build and tag our image locally. Note that the command takes a few parameters. The T parameter is used to give our image a tag. The no cache parameter ensures that there's always a fresh build and the existing local Docker image gets overwritten. The Docker build process is complete, but one thing you want to make sure is that you are running the command in the directory where the Docker file exists. So I switch to that directory before I run the command. From Docker Desktop, we can see that our image is present. Also, make sure you log into your Docker Hub account before we push the image. The last command simply pushes our local Postgres image to the remote Docker Hub repo. Our image has been pushed. You can also verify this directly from Docker Hub. Our custom Postgres image is now publicly available and can be used in any Helm chat for deployment. What we're going to do next is to update the Helm chart with our custom Postgres image instead of the Bitnami image. One thing about tags is that you can use latest or a different number to identify which version your image is. It's best practice to identify your image with numbers instead of using latest all the time, but I use latest for simplicity. The last thing we're going to do is to update our Helm chart with a custom Docker image instead of the one provided by Bitnami. Remember from the README, we're shown how to do this. You simply have to update the image values from the values.yaml. Our registry is docker.io. Our repository name is as shown below, and the tag is latest. Our Helm chart will now use our image, and in the next section, we will simply push our code to GitHub.